Hi there, folks. Today we're looking at the slopes of parallel and perpendicular lines. You've done a lot of this probably previously in algebra, but we'll kind of review the algebra stuff and then we'll look at it from a more geometry type of perspective. So, parallel and perpendicular lines, remember, parallel lines are coplanar lines that never intersect. And the thing about parallel lines, their slopes are the same, all right? So, from that algebraic perspective, their slopes are the same. Perpendicular lines are lines that intersect at a 90-degree angle. And again, from the algebra perspective, perpendicular lines, the slopes are opposite reciprocals. So perpendicular lines, slopes are opposite reciprocals. All right? For example, if I look at something like these guys, it says find the slope of the line, then state the slope of the line parallel and the slope of the line perpendicular. All right? So I'm going to find the slope, then the slope of the line parallel, then the slope of the line perpendicular. And so as I do this thing, I'm going to do that whole change in y over change in x thing. That is the easiest way to do slope. But again, it requires a little bit more mental processing power. All right, so if you need to take it off to the side and do your old slope formula, the y sub 2 minus y sub 1 over x sub 2 minus x sub 1, that is fine, just fine. All right, but I'm going to stick with that change in y over change in x. So here we go. Let's find the slope of this line. Change in y. Y was a negative 3, now it's a positive 7. Think about it on a number line. To get from negative 3 to positive 7, it's gone up 10 units. So it's a positive 10. And then change in x, it was a 2, now it's a negative 4. Think about it on a number line. To get from 2 to negative 4, I have to go down 6 units. So I write this as a negative 6. So the slope of this thing is a negative 5/3. Okay? So that's the slope of the line. Let's talk about the slope of the parallel line. The parallel line should have the same slope. So if my slope was a negative 5/3, the parallel line should also be negative 5/3. And then the perpendicular line, it's a little perpendicular symbol here. Perpendicular line is the opposite reciprocal. So opposite means I change the sign. Remember, a negative sign is like an opposite sign. So if I'm doing the negative of the negative or the opposite of a negative, it's going to be a positive. All right, so I change the sign. And reciprocal means I flip the fraction. So I flip this thing. So change the sign and flip it. Instead of a negative 5/3, it's going to be a positive 3/5. Okay, so slope of the line, parallel line, perpendicular line. All right. If I look at the next one, same kind of thing. The slope of the line, change in y over change in x. To get from a 1 to a 4, you got to go up 3. That's the change in y. To get from a 0 to a negative 2, you go down 2. That's the change in x. And then I would just rewrite this as a negative 3/2 and put the negative with the numerator or stick it out front. We don't typically write it with the denominator. All right? And now the slope of the parallel line. Remember, the parallel line has the same slope, so negative 3/2. And then the perpendicular line, the slope is the opposite reciprocal. So I change the sign and flip it. That's a positive 2/3. Okay? So again, parallel lines, the slope is the same. Perpendicular lines, opposite reciprocal. If I look at something like this guy, again, we're going to find the slope. Change y over change in x. So the change in y, it went from a 2 to a negative 8. So that's down 10 units, so negative 10. The change in x from 5 to 5 is a change of 0. Hasn't moved. And remember, you can't divide by 0, so that's undefined. Okay? So the slope here is undefined. So the parallel line, remember, the parallel line has to be the same slope. So if the original slope was undefined, the parallel line is also undefined. And then the perpendicular line is the opposite reciprocal. Well, it's kind of hard to take the word undefined and change the sign and flip it, right? So you have two options here. You can kind of think about it more holistically and say, you know what? I understand that an undefined line is a vertical line, and I know to have a line that's perpendicular or vertical line, it's got to be a horizontal line, all right? And the slope of a horizontal line is 0. So there it is. Perpendicular, it's got to be a slope of 0. All right, and that's just our understanding of what undefined means and what a slope of 0 means, okay? The other option is to go back to a time when you had numbers, like right here. See, take that piece, when you had numbers, change the sign and flip it. Now it's a 0 over positive 10, which is indeed 0, all right? So I think it's easier, obviously, to think about it from the perspective of, well, undefined is a vertical line, all right, perpendicular is a horizontal line. But again, if you need to go back to the numbers, go back to the numbers. All right, parallel lines, the slope is the same. Perpendicular lines, opposite reciprocal. Now, writing equations of lines. Again, this is review from algebra, but there are two options here. This second one is probably the easier of the two options, but it's the one that students tend to abandon because they forget how to write equations in point-slope form. We just throw that one out the window because we don't use it as much, all right? But by far, I think the easier of the two methods in terms of the thought process involved. So the other option is going right to y equals mx plus b. You find the slope, you find the y-intercept, and then you write it as y equals mx plus b. The other version, when you use point-slope form, you just find the slope, and then point-slope form writes itself, all right? From there, if we want to write the equation in slope-intercept form, y equals mx plus b, we just have to rearrange it. For example, if I look at something like this guy, I'll do it twice. Again, if you want to find the slope and the y-intercept, just start off this way. You find the slope. Change in y, it went from a 5 to a 9, so that's up 4. Change in x went from a -1 to a -3, that's down 2, so the slope is a -2. And then to find the b value, so I found m, now I need to find b. To find b, I just start with y equals mx plus b. And from here, it's just substitution. I know m is a -2. I know b is the thing I'm looking for, so I just need an x and a y value to plug in. Well, here's one right here. There's an x and a y value I can plug in. So I plug the 5 in for y. I plug the -1 in for x. And now I can solve. I solve for b. So I simplify. Hey, that's a positive 2. I subtract that 2 from each side, and I get b equals 3. Okay? So now my equation is y equals -2x plus 3. There's the equation. All right? Option number 2 is to go the same route at first to find the slope, but then we're going to plug it into point-slope form. Okay? So I find the slope. Change in y is a 4. Change in x is a -2. So that gives me a -2. Same as what I just did a moment ago. All right? But now from here, point-slope form. Remember, point-slope form is y minus the y value equals m times x minus the x value. And really, it's the x and the y value of an ordered pair. So I plug in the slope as a -2. And then I just choose one of the ordered pairs. Maybe I choose the first one. So here, it's -5. Because remember, in that formula, there's a minus sign, so that's like an opposite sign. So if I see a +5, I put a -5. Here I see a -1 for x, so I put a +1 over here. All right? That's the equation of the line in point-slope form. All right? We don't typically use point-slope form as much. All right, so typically we want to rewrite this in something like slope-intercept form. It really depends on the question. To rewrite it in slope-intercept form, I just distribute. See, I'm solving for y. And now I add that 5 over to the other side. And when I add that 5, look at that. I get the same thing. Y equals a -2x plus 3. All right? I think that method is probably easier, but if you don't remember point-slope form, that method is impossible. All right? So you might have to go with the first method. If you remember y equals mx plus b, well, that's the one you got to use. Okay? If I look at the next one, it says write the equation line that's parallel to y equals a -3x plus 4 and passes through the point -6, 4. And so once again, I'm going to do it twice. If I'm going right to y equals mx plus b, I need to find two things. I need the slope, and I need the y-intercept. I need the m and the b. Well, it says that I'm parallel to this line y equals a -3x plus 4. So y equals a -3x plus 4 has a slope of -3. If I want to be parallel, it means my slope has to be the same, so my slope has to be a -3 also. It's the slope of the parallel line, okay? And now from here, to find the b value, I just plug it into y equals mx plus b. I start with a fresh y equals mx plus b, and I plug in. I know m is a -3. I just need to plug in an x and a y value. Well, looky here. There's an x and a y value I can plug in. So I plug the -6 in for x, and I plug the 4 in for y. And now I simplify. That's an 18. I subtract the 18 from each side, and I get a -14. Okay? So that, once again, is my y-intercept. Now I write my equation, y equals mx plus b. So y equals -3x minus 14. Option number 2, ready? I got to start off the same way. I have to find the slope. And I find the slope the same way. That's no different. This one, I'm parallel to that line, so my slope's going to be a -3 also. All right? The only difference now, instead of plugging into y equals mx plus b, I plug it into the point-slope form. So I take my ordered pair, so I do the opposite, so that's a -4. Here I do the opposite, that's a +6. The slope I already said was a -3. And now from here, I'm in business. I just distribute, move some stuff around. I can rewrite this in slope-intercept form. So here I distribute -3x minus 18. And I'm going to add that 4 to each side. And of course, once again, I get the same thing. If I don't get the same thing, I probably messed up one of these guys, all right? If I look at this one, write the equation line that's perpendicular to this guy and passes through the point 3, -1. So once again, I'm going to approach it the same way. If I do the first method, I got to find the slope and the y-intercept. To find the slope, I want to be perpendicular to this line. So right here, this line has a slope of -2, which is like -2/1. So I want the perpendicular line, so my slope's going to be positive 1/2. I change the sign and flip it, opposite reciprocal. And now to do y equals mx plus b, I start with a blank y equals mx plus b. I just plug in what I know. I know the 1/2. I know the x value is 3. I know the y value is a -1. And now I can solve for b. Here that gives me a 3/2. I'm going to subtract that 3/2 from each side. And you might have to take this off to the side and work a little magic here. Get common denominators, all that fun stuff. Looks like a -5/2 from where I'm sitting. Okay? And now I can write my equation. And yeah, if you need to take that off to the side, take it off to the side. Do it. All right? Hopefully you're good enough at fractions by now that you can maybe handle that one. If not, it's not a big deal. Maybe you need to see me take it off to the side. Ready? -1, and then I subtracted the 3/2 from each side. -1 is like a -2/2, same thing. And I'll subtract the numerators, denominator stays the same, -5/2. Okay? If I go over to this other version, I do the same thing. I find the slope the same way, opposite reciprocal. It's a positive 1/2. But now I go right to point slope form. I know the slope is 1/2. Opposite of the x value is a -3. Opposite of the y value is a +1. And now I distribute, move some things around, and I'll be back in slope-intercept form. Distribute. And I'm going to subtract that 1 from each side. And I'm in the same situation. A -3/2 and a -1 is a -5/2. Okay? And yeah, you might still have to take that off to the side and get your common denominators. Okay? Parallel lines, the slope is the same. Perpendicular lines, opposite reciprocal. We can use that to determine the equations of other lines as well. All right? And again, for writing those equations, either find the slope, find the y-intercept, plug it in, or point slope form and rewrite it in slope-intercept if we need to. All right? Now, from a geometry perspective, here's some of the things we might see, all right? We're going to start plotting points in the coordinate plane, and maybe we want to know, all right, what kind of shape are we dealing with? Does that shape have parallel lines? Does it have perpendicular lines? And those are things that become really important as we kind of move forward. So if I were to plot these points, and I'm going to color coordinate them because, I have them written that way. So let's see, 4, 2 is right here. That's point A. -5, 5. Right here. 6, -2. And 0, -5. Okay? And then it says determine which lines are parallel and perpendicular. So the idea here is we kind of want to look at this and say, okay, let's actually draw these lines maybe. All right? So maybe if I draw this line, and I draw this line, and this one, kind of making a shape here. And as you look at this thing, because this thing is drawn to scale, all right, we can use a little bit of judgment here as we kind of look at these. It might be beneficial to just find the slope of each of these. But let's just go through and find the slope. So up here, if I found the slope of AB, let's find the slope of this line. And I could use rise over run, or I could look at the 2 points that I'm talking about, which is these two. And I could do change in y over change in x. So change in y is a positive 3. Change in x is a -9. So that's a -1/3 for the slope of AB. Okay? And now go through and find the slope of each of these. Let's find the slope of this one. Maybe I want to do down 1, 2, 3, 4 over 2. So down 4 over 2. Oh, that's a negative 2. There's the slope of that guy. Maybe I find the slope of this one and say, oh, that's up 1, 2, 3 over 1, 2, 3, 4, 5, 6. So up 3 over 6, that's a slope of 1/2. And again, you can use the graph or you can use the points that are given to find the slope of each of these. The only thing I would caution you about is I just kind of free-handed these lines. I don't want to trust all the points that I graphed in between unless I use a straight edge. So if I want to count the slope from something like B to something like D, I have to count all the way from B to D. I have to count down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and over 1, 2, 3, 4, 5. So it's down 10 over 5, so that's a negative 2. Okay? Don't trust those points that are in between because I didn't use a straight edge. If you use a straight edge, you can trust some of those. Okay? But now compare the slopes. In order for lines to be parallel, the slopes have to be the same. Do I have any slopes up here that are the same? Well, yeah, I've got a negative 2 over at BD, and I've got a negative 2 over at AC, so those are parallel lines. So line AC is parallel to line BD. Okay? And then perpendicular means opposite reciprocal, so I'm looking for two values that are opposite reciprocal, so different signs but flipped. Well, yeah, negative 2 and a positive 1/2. So when I look at that, it's showing me that line AC is perpendicular to line DC. And I know that because a negative 2 over 1, and a positive 1 over 2 are opposite reciprocals. But there's another guy in here that also fits that description. We've got line BD is also perpendicular to line DC. And remember some of the properties we have with parallel and perpendicular lines and some of the postulates and theorems we looked at. Here's two parallel lines and a line that's perpendicular to one of them. It's got to be perpendicular to the other parallel line. This is kind of that postulate, that theorem we had in action. All right, this is one that we proved previously. If I look at something like this guy, I'm going to plot these points once again. So 3, 2, right here. Negative 7, 0. And 4, negative 3. Okay? And it says determine if triangle ABC is a right triangle. So let me draw this triangle. And I want to determine if this is a right triangle, which means I have to see if any of these angles are right angles. In other words, are any of these lines perpendicular? And here's the thing, I could check each of these. It's probably not going to be this one over here by B, and it's probably not going to be this one over here by C. The one that I would probably want to be most anxious to check is the angle at A. I want to see if that is a right angle, so I want to know if BA is perpendicular to AC. And once again, I have to find the slope of these things. So like here, if I found the slope of this guy, it's down 1, 2, 3, 4, 5, and over 1, so that's a slope of negative 5. If I looked at BA, it's up 1, 2 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that was up 2 over 10. So that's a positive 1/5. And then if I really wanted to, I could check the slope down here on this guy, of course. Let's see, that's down 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Down 3 over 11. And again, that one was never really in contention because this thing is drawn to scale. So now I just want to know, hey, is BA perpendicular to AC? And the answer is yes, they're opposite reciprocals. So if they're perpendicular, it means that this guy right here is a right angle, which means this is a right triangle. So yes. Okay? But But again, we're using the idea of parallel and perpendicular lines. We're plotting them on our Cartesian coordinate plane, and now we can make determinations about the shape that's been created. All right?